2 here times 2. Okay, so that's going to give me 40 on the left. And 1/2 of 2 is 1, so I'm left with just 95 minus x on the right. Subtracting 95 from both sides, I get negative 55 is negative x. But I don't want negative x, I want positive x. So multiplying both sides by negative 1, x equals a positive 55 degrees. All right, so this is the measure of that arc there in blue. Okay, what's next? We got 2 more examples. Okay, again, we're looking for the value of each variable. So why don't you take a minute and see if you can solve for those 2, and then we'll come back and we'll see how well we did. Okay, so in this next example, we're looking for W. W is this arc here in yellow. Okay, we know our smaller arc, our blue arc, is 110 degrees, and we know this angle here is 70 degrees. All right, so using our formula from our theorem, we know that the measure of our angle, which is 70, is 1/2. Since our intersection's outside, we're going to take the difference of our 2, so we've got W minus 110. Okay, and again, we want to solve for our variable, which is W. So I'm going to start off by multiplying both sides by 2. I want to get rid of that 1/2 fraction there. Okay, so 2 times 70 is 140. And 2 times 1/2 is 1, so we're just left with W minus 110. And if we add 110 to both sides, to get that W by itself, then we get W equals 250 degrees. Okay, next up. Now we've got an angle Y outside the circle, and we've got the intercepted arcs of 110 and 30. So Y equals 1/2 of the difference of our 2. And again, remember to put the bigger angle first so we don't get any negatives. Okay, 110 minus 30 is 80, and 1/2 of 80 is 40, so our Y is 40 degrees. Okay, great. So our next theorem, and our last theorem for this unit, Theorem 1112 says for a given point and circle, the product of the lengths of the 2 segments from the point to the circle is constant along any line through the point and circle. It's a mouthful. What does that mean? Well, we've got, again, 3 different scenarios. So let's take a look at each one separately. So scenario number 1. Okay, in this case, we've got 2 chords that intersect inside the circle. And when they intersect, they form 2 pieces on each chord. So notice we've got an A and a B piece, and we've got a C and a D piece. Okay, so what this theorem says is that the product of each chord's pieces is equivalent. So A times B equals C times D. That's interesting. Okay, scenario number 2. Instead of chords, we've got secant segments. They intersect outside of the circle. So what this says is that instead of the product of the parts, we've actually got a part. So W is the outside part of that segment times the whole. So W plus X is the whole secant segment. Okay, and that should be equal to the part on the outside, Y, times the whole of the other segment. Okay, Y plus Z is the whole segment. Okay, and scenario number 3. We have a tangent segment and a secant segment. So the same idea goes. This time, since the tangent segment doesn't enter in the circle, then we do the outside times the whole, which is really the same thing. So we've got outside times the whole. So that is why we have t squared, because we have t times t. So then for our secant, we've got the outside times the whole, y plus z. Okay, so let's see what we can do with this theorem. Let's look at a couple examples. All right, first one. It says find the value of the variable. We've got a circle with two secants. We've got an intersection on the outside. So our y, we're going to set up our equation just with the theorem we just learned. So our outside, 6 times our whole, which is 6 plus 8, equals the outside times the whole, which is 7 plus y. Alright, so we want to solve for y. Let's go ahead and simplify the left side of that equation. 6 plus 8 is 14, so we've got 6 times 14. On the left side, I'm going to go ahead and distribute my 7. So I've got 7 times 7 is 49. 7 times y is 7y. Okay, 6 times 14 is 84. I'm going to come up here. So we've got 84 equals 49 plus 7y. And solving for y, we're going to subtract 49 and divide by 7. I'll leave the algebra to you. Should get y equals 5. Okay, so that piece right there, that little chord in there, should have a length of 5. Okay, next example, we've got z, which is a tangent segment out here. And we've got a secant segment with the outside of 8 and an inside of 16. So let's set up our equation. We've got, for z, we've got the outside times the whole, so that's going to be z squared. And for our other segment, we've got the outside times the whole, so the whole is 8 and 16. Okay, so z squared is 8 times 8 plus 16 is 24. 8 times 24 is 192. So z squared equals 192. We want to square root that and simplify. When we do, we get z equals 8 root 3. Okay, and for our next two examples, I'll leave those for you to do. We will go over those in class tomorrow. That is solving for segments and angles inside and outside of circles.